So you all have decided to change to shift forward the submission date kan? I lupa dah berapa bulan itu. But still within the time. Berapa bulan dah? Lupa dah. 27 je ada ni 27 you shift to 27 this month. Yeah. But before that pun, I think before you complete pun, I will issue the task on 3 first. Tak mesti buat, you baca dulu lah Tapi task 3 ni boleh submit masa exam week tu, masa exam week. Because task 3 basically is something that will replace the exam question. Okay, there's no exam, no written exam, but you do a final assignment that is supposed to be done during exam week. So in fact the department decide to do, mudah bagi 3 hari je, kata kuat tak sempat 3 hari tadi. So we give extra nanti bagi time nanti lah that one will be given. I'll give the so-called the assignment question earlier before you submit your task 1 and 2 ni, just for you to understand kalau you happen to be passing through all this. Ni ada you do some preparation there lah. Ni individual. So far so good lah for your assignment 1 tu, bagus Setiap setengah tu be misunderstood aja What happened to the rest ataupun dia sharing sharing komputer Tengok kayu dengan dawa ni sharing komputer. Nanti I cuba upload lah Kita slowly kita ni lah. Kalau siapa tak ni boleh dia refer pada recorded lecture nanti. Upload uploadkan punya. Alright, so today boleh nampak semua? Can you see?
Nampak.
Nampak. Okay, Alhamdulillah. So that's already 2:30. I think we slowly got to move on. The rest probably can join later lah ataupun they see the slide. Let me see the slideshow there. I hope it works. Bismillahirrahmanirrahim. Alright, so as we are going, bukan lecture 9 kan? I dah lupa dah copy lupa nak update ni. This is lecture 11 lah today Okay. So it's about application of steel reinforcement. So you are coming to a slightly detailed end of the topic on the on this steel structure, which I think is we have to cover everything about steel structure except for some advanced structure like that one. Later on, we do a master program. There will be another topic. I'm going to get into this one, which is more an advanced one. This more to expose you the kind of the material that can be applied to your building design, and you start understanding what steel can be one of the main component of a building. Other than for the structure, so some other part of the building can still be used. As I was mentioning earlier on, because steel, particularly in Malaysia, we use it as a structural component, especially in, for example, this steel reinforcement is basically used everywhere because we basically use concrete in our building, concrete post and beam. Maksudnya the tiang or the beam for the building, whether it's a double story or mid-rise or high-rise building. Most of the column and beam are used this kind of steel to strengthen the so-called structural system for the building. Okay, we'll go through. As I was mentioning to you already, I've gone through. We got another 3 more lectures, which I think this tomorrow I'm not available tomorrow. We may have to shift another day. But it's quite a small, short lecture. Steel failures and bylaws. Bylaws is just few section only in bylaws mention about how to protect steel structures. Deep piling maybe there's one lecture on itself. The innovative design we can join. Maybe let's see whether I can join it with these steel failures or not to do one lecture. But maybe take about 2 hours, a bit more, maybe 1-2 hours. Okay, but today we are looking at the question of steel reinforcement. Okay, what is the meaning of steel reinforcement. So you can see all this form of steel is very raw. It come in long, very long. It's textured. They call it deformed. Finish. So rebar. Another meaning of another name for steel reinforcement they call rebar. It's a short. It's the short form of reinforcing bar. Reinforce. They reinforce the material, the concrete. It is also known as reinforcing steel or reinforcement steel. Steel reinforcement are steel bars. They come in long bars. They are provided in combination with plain cement concrete to make the reinforced concrete. It has to combine with the concrete. Concrete they has tak ada such a you cannot take stress. Will break. I got 2 videos after I can show you the concept of embedding this steel reinforcement into a concrete. So hence the structures from steel reinforcement cement RC, RCC in US panggil RCC, kalau kat Malaysia panggil RC. RC concrete, reinforced concrete. Okay, steel reinforcement is commonly okay. I mentioned to you they call also rebar. Oh, sorry. Alamak, tak nak jalan tak ya. It's not moving. Sorry, wait. Okay. Why need to use steel reinforcement? Steel is used for reinforcement because it is form of a strong bond with concrete and expand and shrink at a similar rate due to the control pressure variation. Yes, normally after you cast, the concrete will shrink a bit. Ada video to show you some of the effect of the shrinkage. And also because the steel is capable of bearing all the 3 forces. Forces and shear moment and axial force. That is concrete. Oh, sorry, I skipped this one. Sorry, this is not. Okay, manufacturing. Rebar commonly manufactured using mine or high steel yield. It's also mine steel. Of course, you got some grade there. You don't have to remember the grade. Characteristic of tensile strength. The constituent of both of these grade are basically 99% iron, along with manganese and carbon, sulfur, phosphorus. Quality of grade of steel dependent on the proportion of carbon. So carbon takes the highest. Oh, no, the smallest. Yeah. So mine steel, the quality depend on the proportion of carbon. Mine coal work steel contain around only 0.25. I think you can refer to our the first or second lecture on this one. The content of carbon in steel. So basically, it's manufactured through the electric arc furnace. I think we have also discussed it earlier on here. Just some diagram on the arc furnace. Okay, scrap metal is collected from various sources and the steel mill and put into the large ladle where the steel is then melted under temperature of 1800 Fahrenheit. In this state, the molten steel will be poured into a casting. So it becomes a bar. Okay, this is the kind of type of reinforcement bar. You can see the kind of, they call it, sorry, this must be not English. Plain is without any textured surface. Deformed is textured space, also diameters, 10 mm diameter, 12 mm diameter, 16 until go to 50. 50 is very big. This for huge building, huge span maybe. Okay, this is some size there. And what's different between the smooth and plain and deformed? It's easy. You can see from the texture of the plane. It is no friction, less friction for plain bar. Of course, there's less bonding, strength with concrete. Good spillage, many would slippage, good slippage used in gates, a window, staircase, or doors. So this is not so much for a structural frame, structural building, floor, slab, or beam. Deform means with all those textured surface. Good friction, of course, we have to kind of grip. This kind of good grip. Good bond strength with concrete. Less slippage. It doesn't slip so much because of the textured surface. So used in all type of RCC or RC concrete, RC construction work nowadays. And so memang this is the kind of thing that we use almost on every building for the construction of such a system. Okay, of course, there's some specification to sort of control the kind of quality of this kind of material. Of course, the American, this based on the American Society of Testing of Materials, they have created this kind of specification. And the number must be identified on the bar side, something like that. This is the size actually. The size, the type of steel symbol must be noted. Like for example, N mean for the bar roll, and W stand for weldable steel. That means the steel can be welded. A stand for roll axle steel. This is kind of symbol they have there. No? And then that the rebar also grade identification must be cited. This is the grade of the application, whether it's 65, 75, or metric. You know? So this is all written on this details here. It's a bit smaller photo, but it's written there. So when the what they call this material delivered to site, it come in big lorries. They load it to the site. Before that, the contractor has to supply or the delivery order. Make sure the order is the same as we expect as it been delivered, and then the engineer will check all this document and the labeling so that the steel that is delivered to the site is according to the specification that been specified by the engineer for such a system. This is to give you some idea of the type of columns that use steel bars and also reinforcement or without steel reinforcement. Okay, but of course the A one we don't use for column because without reinforcement, probably for stump if possible. You know, stump, the short column to support the timber column, like they use it for our kampung houses, stump. But for B, of course, this is for whatever building want to build. It depends on the size of the column to take up the load. Depend on the load of the building. I show you after the KFCC super column they call it, mega column they call it, a huge column. Okay, this is the one the below is what you can do. You cannot, for example, the middle reinforcement there is concrete column they call it. Concrete means that it is not using steel per se. I mean, it's not the one like below. For your building, your gallery, you can use all those column indicated in the lower images. You can encase in a concrete, yes, no problem. Or you can expose it, encase with some kind of box or whatever things. Even you can expose it if you want to keep it like that, and pair it nicely. Then you get look very nice. This one can apply for your building. This is another concept showing the so-called how all these reinforcement be wrapped around the what's it called, this vertical reinforcement. For a tie, we call it simple tie, or stirrup they call it, or transverse tight column. And the spiral column, it goes like diagonally, it goes around, And then composite column, you use this either this empty, like you have just steel tube, big steel tube, you pour in concrete inside, or the other one, the H beam for column, H beam. Then you just put additional reinforcement outside there, and then they pour in concrete. It's composite column. They mix it together with reinforcement bar as well as the universal beam. This one I can use also in your building. This is another images to show it in 3D. Of course, there are some certain details. You look at the engineer drawing, there are a lot of details showing all this. For us, it's enough for us to actually understand the so-called house being fixed, and the rest of the engineer will have to check and they have to endorse the approval whenever they do the inspection before concrete being poured into the formwork. Okay, there are different type of rebars. Okay, rebars may increase the tensile strength of the structure. Okay, rebar surface often deformed to promote the better bonding, as mentioned just now. There are also different type of rebar, namely as follows. We go one by one. European with rebar, this is quite standard, but we don't see maybe European. But again, it is almost similar thing, except the quality is different. It is least resistant type of rebar, which bend easily, can be bent easily. So it is easy to work with. It is generally not recommended for use in areas that experience earthquakes or no project that require substantial structural integrity from this rebar. So this is something like, I don't say second grade, but something like lower than the normal strength of a rebar. Carbon steel, the most common one. That is what we use here in Malaysia. Yeah. They call it common black bar, or used in every type and scale of project with few exceptions. The biggest weaknesses of black rebar is that it easily damaged and deteriorate. Also cracking, expand cracking and breaking the concrete around it. However, this black rebar is available easily. But of course, they have all sort of ways to prevent the cracks. So far, there are not many say building that is failed because of due to the wrong placement of rebar or wrong choice of rebar. So far, so good. The cracking mostly happen on the surface lah. Maybe due to plastering whatnot. I think we'll see some of the one video they show about this, about cracking. And epoxy coated, basically it is to prevent corrosion. Of course, this rebar, the first two rebar, carbon steel and European steel, it is subject to corrosion. When you expose it outside, then you can see it corroded. But of course, after you can see use it after cleaning it, then you can use it again. You see uncompleted building, you see all those rebar protruding from the columns or beam and exposed, all got rusted. If the rust is too extent severe, then you got to replace with a new kind of reinforcement. Okay, if possible, basically to prevent corrosion. Manufacturers cover the entire bar with coating epoxy. This water impermeable layer minimize the chances of corrosion. Will take hold of the rebar. But just for info, the Australian, no, Canadian, Quebec City banned this epoxy coated rebar because due to the handling, some of the rebar damaged. So they create some holes along the the rebar, and then it subject to rust. I mean, so that so-called epoxy coating too is not that functional. So a lot of damage is done during the handling. So they not so much encouraged to do this, right? Unless you want to use stainless steel. I show you stainless steel afterward. Galvanized rebar, this is more is better than the normal rebar because of the protection against resistance and corrosion. Coating of galvanized rebar is more difficult to damage. Let's say this 40 times more resistant corrosion than the black rebar. I mean, it is good, like this good, but of course it comes with a cost, expensive. It has more value than the epoxy coated rebar. Of course, it's also more expensive than epoxy coated rebar. Of course, because you go through, I don't show so much of this process of coating. This is just like a process of galvanizing whatever the seal. Not for this. Okay, ada juga saya saw di videos on this one. So mungkin tak perlu tunjuk lah. You can want to know, you can actually assess yourself. The other one is glass fiber reinforcement polymer. They coated with glass fiber. And so the rebar itself is made of glass fiber instead of steel. Okay, that is composite such as like carbon fiber. As a result, field bends are not permitted when using GFRP. However, it is not corroded. And then in that respect, GFRP is an unparalleled concrete reinforcement bar. So it costs 10 times more much than a epoxy coated. It's more expensive. Assembly light, but of course it's light because fiberglass. It's very light. So the cost is only about double than considering taking the linear feet. So basically, but it's not found here in Malaysia. We seldom see this. I seldom see it during my practice. Maybe overseas country, but we don't quite use it because they were saying that it's difficult to bend. And then stainless steel rebar, this is the most expensive of all. About 8 times, and then price is epoxy. Also the best rebar available for most projects. It's known for its powerful one, but it's more resistant to damage than any other corrosive resistant material. Okay, of course it can be banned in the field, but we use stainless steel for exposed kind of environment. Talking about using stainless steel railing. It's more for the exposure to rain or even sun and rain. But this one is going to be embedded in a concrete. Maybe unless one doing something very expensive building, okay, like I don't know whether Brunei sana pakai use this one or not. Probably you can use this, right? Or you want to expose it Okay, and yeah, you can. I'll show you one video. This is just introduction first.
Did you know the greatest reinforced concrete structures today wouldn't exist without broken flower pots? My name's Tyler Lay. I'm a concrete freak, and this video is for you. Joseph Monet, a French gardener, go France, developed reinforced concrete in 1867. Monet was tired of his clay pots breaking. So what did he do? He tried something new, tried something different, and it worked. He filed for a patent for reinforced concrete, for combining steel and concrete together to help hold his pots together. They would still crack, but he would keep those cracks small. He had big pots, small pots, all kinds of long, crazy thing. The dude's a visionary. I've never even seen a pot like that, but Monet was already investigating and developing it so many years ago. So when you see a crack like this, think like Monet. I'm just going to keep those cracks small. I'm going to put reinforcement across it. There are all kinds of different ways to do this. I'm not going to talk about all of them, but I've got videos on most of them. You should check it out. But how do we know where the cracks are going to form in our concrete? And the simple answer is, where is the concrete trying to get longer? Longer? Yeah. Where is it trying to get longer? This is called tension. Let me show you what I'm talking about. If I have concrete and I pull on it, it actually doesn't take a lot of load to make it crack. But if I have reinforcement inside of it, those cracks, they still form, but they're small. And we'd like those cracks, ideally, to be less than 0.004 inches. That's what ACI 350 says, that water or fluids won't penetrate it. We don't have to have them that size, but that's what's ideal. If you want to learn more about this and how to control cracks, you can watch this video. But how do we figure out where the tension is? Well, to do this, we have to become the structure. And we have to imagine the structure deflecting under load and then put that reinforcement where there's tension. And have you seen cracks on previous projects? That means they didn't have enough reinforcement there, because we like those cracks to be so small we could barely see them. Let me show you what I'm talking about. If we have a beam that's on supports and we idealize if gravity starts loading it, it's going to make it move like this or deflect. And at the top, it's going to be getting shorter. At the bottom, it's going to be getting longer. We call the top, it's in compression, and the bottom, it's in tension. So where do we need the steel? The bottom, of course. We're going to put it near the tension face. So how much reinforcement do I need? Well, it depends. Yeah, depends aren't just diapers. It depends on lots and lots of different things. And that's why we have engineers. They help us figure out these problems and calculate and see exactly how much we need. Go engineers. But ideally, we'd have closely spaced reinforcement that's placed very close to the surface. Not too close, because we don't want to have corrosion, but close enough to help keep those cracks small. And that's why I'm a big fan of deformed bar mats. They're really small bars that are closely spaced, that are deformed, so they're still going to grab onto the concrete. I'm also a fan of combining reinforcement and fibers together. You will get improved performance with them both together. I talked about this in this video. You should check it out. Now, if we have another type of beam, a cantilever beam, one that's kind of hanging off a cliff, if we do our job to think about how is it going to move, it's like this, and there's going to be tension at the top. So that's where we need our reinforcement. Now, if we have a really long beam with lots of different supports, let's think about it deflecting. It's going to look like this. Where's their tension? There, like all over the place, right? But what happens here? Well, it's getting smaller there, right? It's compressing. But when we put reinforcement in it, We usually, at least in my country, put it almost everywhere. Why? Why would we put rebar where we know there's compression? Well, there's a couple good reasons. Well, one is it decreases labor costs. If I'm already extending the bar, I might as well keep it going. And two, the theory is not always right. We don't always know where the tension is going to be. And sometimes, especially in elevated slabs, we need to protect ourselves from surface cracking. So we put our steel in a lot of different places. How about on the ground? Now, you look at this and say, it can't deflect, right? Think about it. Where's it going to move? But as concrete dries, it shrinks. It's like a sponge. It's going to shrink. And the ground underneath it is going to restrain it or hold it. It's going to keep it from moving freely. And this is why people sometimes put plastic underneath their slabs, usually 2 sheets with at least 15 mils. Here's a whole table of different friction coefficients that ACI 360 has put together. This is how hard it is to get your slab to move over these different surfaces. And we'd like the lowest number, hence the 2 sheets of plastic. But if the concrete dries more at the surface than at the bottom, it's going to curl. It's going to move up and curl. And if there's load on the edges, oh no, it's going to crack. I hate corner cracking. How do we stop this? Reinforcement, right? We'd like to put the steel near the surface to help keep the cracks small. That's where people are going to see them. A good number is about 1.5 inches on an interior floor slab. Are there other places we need steel? Yeah. Sometimes on reentrant corners, a crack is going to want to form there. When we're about to pour the concrete, you'll see these diagonal bars there, and we get them as close as we can to that surface, maybe an inch away, just so concrete coats it. So in summary, find the tension. Then use reinforcement to stop the cracks and learn from your past projects. If you've seen cracks other places, then you know how to stop them. And remember the cracked pots. Remember what Joseph Monet did. He had a problem and he came up with a solution. The world needs your ideas. Don't be satisfied with the status quo. Don't be satisfied with the problems you put up with every day. Don't give up. Come up with innovative solutions. We need you, and maybe you will be the next Joseph Monet. Viva!
Okay. All right. Let's continue. Yeah. Tadi he also was talking about this material, but I lupa nama tadi. Here we call it welded wire fabric. Oh, kat sini dia panggil macam wire mesh ya. Tapi wire mesh tu more on small scale. In this case, it doesn't come with a long rod, as we mentioned earlier on. This is the most favorite kind of fabric welded wire material used for concreting. I think most of my building we use this kind of thing. It's faster. It's already been jointed and welded in factory. You just come and cut and lay at the right place, and then tie all the joints together. So it's very fast. So this is, we call it a welded wire fabric. It's a product started of fusion, welded low carbon steel or stainless steel joined into a square grid pattern or mesh in common sizes. That is used for reinforcement of concrete slab. It serves to enhance the tensile strength of concrete slab. In some manners, it also used as other type of rebar. So basically, I show one example I've built. I mean, I used for my one project back in 1993. It's quite interesting project. Okay, what else do we have here? Oh, it's not moving. Sorry. It's more. It's very fast. The way we do, because we don't need people to actually do all this tying up all those long reinforcement. I show you what the disadvantages of it. Okay, not disadvantages, more advantages. Okay, basically, welded wire mesh is made of high quality low carbon wire, and then through a fully automated computer control welding machine. It has several advantages, and a few of them are explained below. improve the self-efficiency and productivity with reduced reliance on manpower on site. Yes. Just imagine the amount of manpower needed to actually just to tie all the pieces together into to cover all the floor slab. That will take a long time. And also sometimes a lot of defect happening when they are doing the tying and the replacement of all those reinforcements. And then secondly, the chance to improper bending of bars is reduced. Same bending machine bend the mat as a single unit. You know, when they want to join, they have to bend all those long reinforcement. When bending, sometimes it may actually not be following the kind of standard specification that's required. This is the factory welding system. You can see the two photographs here in the middle photograph, how they actually welded perfectly according to the size. So without any failure, the product there. And then provide the exact size reinforcement where needed through variable of bar sizes spacing. Yes, they got varieties of sizes and degrees from small to big. Okay, welded wire mesh can be placed in position relatively faster as compared to placing of individual bars and tying them in a place. The result is the reduced cycle time of slab casting. Yes, this is time is already very critical in construction. So whatever thing they can save, so the best solution is using this white fabric, welded white fabric. Then reduce construction cost due to enhanced speed of construction. Of course, one of the construction speed, you reduce the time of construction, they'll be saving a lot of cost, especially on your overhead. And more, basically, welded wire mesh can be manufactured from rolls instead of a stock of length bars, thus minimizing the wastage. When it comes in rolls, they combine together, then it form the rounded so-called each reinforcement, then pass through the machine, they weld it together. So welded wire mesh also require lesser storage as at the side. You can stack, as size you want here. Here's something example here. You can stack, Cutting, bending factory eliminates the need of rebar inside. So this is where you need workers to do the cutting and also the bending. This is a bending machine here. Bending and bending machine to bend all those reinforcements so that they can be formed into a beam or slab. And then factory production inherently safer as compared to bending rebar at the side. Of course, this factory is very controlled. You know that whatever has been cast or done or precast or do it in the factory, of course, it is very safer than actually at the site. Of course, we mentioned about fast erection time, and then mesh stay where you put and has excellent adherence to concrete. Of course, you place it, instead of 1 or 2, you can place a huge like 2.4 by maybe 2.4, 2.4 or 2.4 by 3 meters, whatever. No? So it's just big and huge and very fast. Easy unloading and installation at the work site. Of course, because 2% can actually lift one of these mesh or the fabric to the place, and then easily you can tie, and some overlapping needed for the joint. So this is just another detail of they call it, and I saw this quite a nice drawing actually. This is some of detailed joint of this more engineering and then our basically beam bar encouraged with simple pin hooks and transverse bar within the bend section. This is the red pin there. Term encourage represent the extension of its reinforcement bar inside the concrete. So in order to achieve the cohesion of the two materials, steel and concrete, with this specific procedure, steel can contribute up to maximum strength. So whatever is required, the encourage can be either straight or hook. So this is some of the details. Look at all this setup. They got setup. It has to be bend 135 degrees. I think this one. Some of the I think the earlier video I missed that we can probably see up to some mistake done at the side when they do all this arrangement or fixing of the reinforcement. There's some other images on double pin. Got double red pin here, and then drum anchorage they put another sort of in the middle of the column there. Another set of reinforcement to strengthen the column. Okay, This some of these what you call this additional kind of component that's required when you do the placing of the reinforcement on the floor at the side. So the first is we call it wire tie. Reinforcement tie is made of any wire for reinforcing steel, and there are various sizes of tie wire for concrete reinforcement of for choice. Tie wire is popular use in the daily life and various industries for binding, typing, fencing, and other things. In fact, they can also use the plastic wire tie, but normally use the steel wire ties also. This one is plastic wire ties. This is a kind of wire ties. How they tie this, the horizontal, vertical, the X, Y of this reinforcement has to be tied together using a simple tool like this. Of course, that day when your senior is doing the IBS at the site, they learn how to tie this. One organizer was actually doing some footing, reinforcement footing. They try this like to tie this one. To tie by hand is a bit difficult, but there's a simple way to do it. But of course, for big project, they have machine to do this. They just put the machine, they tie very fast, and this one for manual. All those have to be tied at a certain level. You saw the reinforcement have been placed one at the bottom to take the tension at the bottom of the beam, and one at the top to take the tension from the top beam. For this case, it's floor slab. You get two layers. Then this another component. They call it stirrup or lateral ties. You can see the vertical here, proportion here for the beam and column. So basically, they are provided to hold the main reinforcement bar together, and they are always perpendicular to the main bar in the beam. All this for 90 degrees perpendicular. And then we know that the beam under loading always elongates. Sometimes it stretch out due to the tensile forces in tension zone and compressive forces in compression zone. Whenever the load acts on it, it causes transverse or vertical tension because of the diagonal shear is produced. That's why that this is important to have that. So this stirrup resists shear failure. Diagonal crack are resisted by this, also by this one, by the stirrup. Shear failure also is called diagonal tension failure. So they prevent the so-called longitudinal bar from bending outwards. So this is more technical. These are all protected to make sure that the system, the beam system is stay intact. There's no what do you call this, extra bending to the beam with whatever pressure they put inside. So the beam will stay straight as it is being designed for. Similar for a column. Sometimes this is the avoid buckling. In column, it receives the buckling failure. So they prevent the column from buckling. So in case when they pour the concrete, so they will stop it from buckling. This column. So in beam, they call it loop or called strap, resist shear failure. But in column, they call it ties. We show now the type of column, we call it ties to resist buckling. There is some of this additional component to do the. This is how some of the sample and the workers is putting the strap together. They has to be placed at certain distance so that the load distributed will be the same. And then there's another one. This is called spacer. What's the spacer in concrete reinforcement? Kalau kat Malaysia ni dia panggil tahu kalau bahasa Cina. Tahu macam tahu tu kan. Letak kat bawah tu to make sure that there's some spacing between the bottom of the slab and the reinforcement. So for your concrete reinforcement structure before pouring the concrete. So there are 4 types of cover blocks for column cover, foundation cover, and piling cover. So this is some of the sample, but not all. In other words, a cover block is essentially a spacer. It's used to lift the rebar matrix off the ground so that the concrete may flow underneath the rebar. So this is also important. I've seen some of this project where the spacer is quite far apart, and then the so-called the reinforcement start to bend. So when it bend, and then it will touch the floor. I mean the formwork below. When the cast, when you open the formwork, you can see part of the bar being exposed It is why that during before they cast many pour the concrete inside, the engineers have to check to make sure that all these concrete block have been placed at the right place, and none of this reinforcement is sagging, so that it won't be touching the formwork at the bottom there. If it touch, meaning that there will be one after you cast, you can see all this bar is being. This is very important. Sometimes me myself, so I have to do some bit of checking. I see some houses, the spacing sometimes it's only like it's supposed to be like 2 inches 50. It's only like not even 12 mm, but sometimes 9 mm, 10 mm. Very shallow from the bottom of the slab. So this is very risky for some additional load. Probably can cause some crack also. So most of the time we depend so much on engineer to check. I mean the site engineers, but sometimes we also have to look before they put the casting. So always at the site, we have a form. Normally, once a contractor has already completed all this placement or reinforcement, they will inform all parties say that for inspection before they pour concrete. And they plan to pour concrete this afternoon sometime. And then they ask us to go in the morning. Sometimes they go 1 day notice. They say tomorrow the what they call this concrete minister will come and pour. But when we check, a lot of amendments we made, then you got to cancel the order. This is very important because suddenly once you pour the concrete, you can't see anymore. You can't see anymore. Everything is inside. Why building collapse? Because certain things that is not properly supervised, or maybe even the design failure for that matter. Undersized kind of undersized setup, undersized reinforcement. That happened. I wish I can show you video on that. Some mistake done. I try tengok nanti we try to. This is another one just to refresh everybody. Some other similarity, but this another aspect how you look at concrete with reinforcement bar.
In the last video, we talked about Concrete 101 and why concrete is such a great construction material, but I didn't mention its greatest weakness. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're continuing the series on concrete with a discussion of reinforcement. This video is sponsored by Skillshare. More on that later. To understand concrete's greatest weakness, first we need to know a little bit about mechanics of materials, which is the fancy way of saying how materials behave under stress. Stress in this case is not referring to anxiety or existential dread, but rather the internal forces of the material. There are three fundamental types of stress: compression, pushing together, tension, pulling apart, and shear, sliding along a line or plane. And not all materials can resist each type of stress equally. It turns out that concrete is very strong in compression and weak in tension. But you don't have to take my word for it. Here's a demonstration. These two concrete cylinders were cast from the exact same batch, and we'll see just how much load they can withstand before failure. First, the compressive test. Under compression, the cylinder broke at a load of about 1,000 pounds. That's 450 kilo. For concrete, that's pretty low because I included a lot of water in this mix. The reason is my rig to test tensile strength isn't quite as sophisticated. I cast some eye bolts into the sample, and now I'm hanging it from the rafters in the shop. I filled up this bucket with gravel, but it wasn't quite enough weight to fail the sample. So I added another dumbbell to push it over the edge. The weight of this bucket was only about 80 pounds, or 36 kilos. That's less than 10% of the compressive strength. All this to say, you shouldn't make a rope out of concrete. In fact, without some way to fix its weakness to tensile stress, you shouldn't make any kind of structural member out of concrete, because rarely does a structural member experience just compression. In reality, almost all structures experience a mixture of stresses. That's no more apparent than in the classic beam. This particular classic beam is homemade by me out of pure concrete here in my garage. Applying a force on this beam causes internal stresses to develop, and here's what they look like. The top of the beam experiences compressive stress, and the bottom of the beam experiences tensile stress. You can probably guess where the failure is going to occur on this concrete beam. as I continue to increase the load. It happens almost instantly, but you can see that the crack forms on the bottom of the beam where tensile stress is highest and propagates upward until the beam fails. You see what I'm getting at here? Concrete on its own does not make a good structural material. There are just too many sources of tension that it can't resist by itself. So in most situations, we add reinforcement to improve its strength. Reinforcement within concrete creates a composite material, with the concrete providing strength against compressive stress, while the reinforcement provides strength against tensile stress. And the most common type of reinforcement used in concrete is deformed steel, more commonly known as rebar. I made a new beam with a couple of steel threaded rods cast into the lower portion of the concrete. These threads should act just like the deformed ridges in normal rebar to create some grip between the concrete and steel. Under the press, the first thing you notice is that this beam is much stronger than the previous one. We're already well above the force that failed the unreinforced sample. But the second thing you notice is that the failure happens a little bit slower. You can easily see the crack forming and propagating before the beam fails. This is actually a very important part of reinforcing concrete with steel. It changes the type of failure from a brittle mode, where there's no warning that anything is wrong, to a ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential catastrophe and hopefully address it before it occurs. Rebar works great for most reinforcement situations. It's relatively cheap, well tested, and understood. But it does have a few disadvantages. One of the major ones being that it is a passive reinforcement. Steel lengthens with stress, so rebar can't start working to help resist tension until it's had a chance to stretch out. Often that means that concrete has to crack before the rebar can take up any of the tensile stress of the member. Cracking of concrete isn't necessarily bad. After all, we're only asking the concrete to resist compressive forces, which it can do just fine with cracks. But there are some cases where you want to avoid cracks or the excessive deflection that can come from passive rebar. For those cases, you might consider going to an active reinforcement, also known as pre-stress concrete. Pre-stressing means applying a stress to the reinforcement before the concrete is placed into service. One way to do this is to put tension on the steel reinforcement tendons as the concrete is cast. Once the concrete cures, the tension will remain inside, transferring a compressive stress to the concrete through friction with the reinforcement. Most concrete bridge beams are pre-stressed in this way. Check out all that reinforcement at the bottom of this beam. Another way to pre-stress reinforcement is called post-tensioning. In this method, the stress in the reinforcement is developed after the concrete is cured. For this next sample, I cast plastic sleeves into the concrete. The steel rods can slide smoothly in these sleeves. Once the beam cured, I tighten nuts onto the rods to tension them. Under the press, this beam wasn't any stronger than the conventionally reinforced beam, but it did take more pressure before the cracks formed. Also, this one wasn't quite as dramatic because instead of failing the actual steel rods, it was the threads on the nuts that failed first. I hope these demonstrations help show why reinforcement is necessary in most applications of concrete, to add tensile strength and to change the failure mode from brittle to ductile. Just like the last video, I'm just scratching the surface of a very complicated and detailed topic. Many engineers spend their entire careers studying and designing reinforced concrete structures. But I'm having some fun playing with concrete, and I hope you're finding it interesting. I'd love to continue this series on concrete, so if you have any questions on the topic, post them in the comments below. Maybe I can answer them in the next video. Thank you for watching, and let me know what you think. Thanks to Skillshare for sponsoring this video.
Okay, so basically you got some idea. Yani because there's a lab test, so I want to show you how it works for a beam, or a simple kind of frame, with and without reinforcement. It's quite useful for you to understand. All right, now we go to the application of of what they call this reinforcement the wired welded wired fabric in one of my project. And then secondly, we go to see the concreting of the KLCC. So back in 1993, I was having at that time I was practicing 1993. Saya tu umur berapa? 40 lebih kot still young. We were doing some small surau dekat RTM, Radio Television Malaysia, Angkasa Puri. So there was a what they call this police beat house, police beat house, like an office, small office, and the rest area for the police. So in the way of the surau, you have demolished the pre-beat house, and then we proposed to the minister at that time, the late Dato' Ahmad Rahmat, said that why not we build something. My experiment on this my for the low cost project. 1993, people never talk about low cost. At that time, there are thousands of units to be built, but nobody interested because the cost is too expensive. To build a small house, it will cost more than 25,000 ringgit. And then how much you want to sell? The government put a selling price of only 25,000 ringgit. So they may not be able to even make a little profit from there. So I tried my own experiment by, I call it pen slab casting, which I reverse the technique using some of these materials. Okay, first I created what they call this a formwork for the beam, for the slab, and I use as a rough foundation. There is no reinforcement by using this welded. It was not shown then. And I showed the other slide. It's laid there as a rough foundation. And then I call in the concrete mixer. We pour the slab together, and just take about not even half a day, but about 3 or 4 hours to complete. Then when I was saying about reversing the technique of construction, if you're talking about the conventional way to construct building, you build the column first, you build the beam, right, and then you put in the wall, right? Put in the wall, and then you start to do plastering and put the window frame on. In this case, I take my what I call this platform for the foundation as a casting yard. My casting yard. That is where I put the wall. I put the wall, I put the window frame, and you can see the welded fabric used for the wall. It's also around the what they call it, the window frame. I use a very small one. I think about 8 mm diameter to cast the wall, and then I lifted the wall. So instead of doing the column first, but I only put the column as you can see the reinforcement for the column standing up there. Okay, and then I put the last slide here below is this lifting bar, the big lifting bar there, so that when I lift, that doesn't break at the corner. So that big bar is for the purpose for lifting. Okay, and then that is how smooth is the wall when you cast on the ground on a flat area, compared when you do plastering on a vertical surface. I mean, sometimes you can control this because it can be wavy. In this case, with the small framework, the more formwork like 100 mm thick formwork by all around the wall slab there, so you can that as a guide so that the so-called the cement, the concrete, you put a bit of cement and then it becomes very smooth and very flat. Even the frame of the door, the window frame, also the same size as the perimeter formwork. And then once it dry, we lift up. Okay, you can see the second slide there. We lift up by crane. I mentioned to you about the lifting bar. There's a lifting hook by the side of the wall there. It's lift up. And then you can see the third slide below here, the bottom left. All the walls will be in place, with opening for the column. Okay, so the column there basically is the reinforcement there is basically is to take up the column. So we just put our small what to call it minimum size of formwork there, and then we pour the concrete. Okay, we pour the concrete. This when we're doing it. So we pour the concrete there. So now the columns will be up and the walls will be up. And then at that time, apparently when I was doing this the late minister dropped by and see us. He asked what you're doing. I told him about after Datuk Rahmat at the time, what we are doing for our experiment house for our low cost housing. At that time, people never thought about low cost, so we reverse the technique. We can do it even cheaper and a lot of advantages to this. So apparently he mentioned that I must bring Mahathir to visit the site. Kata, oh, betul that, you know. So apparently on 9 December 1993, Mahathir visited the site. So I have to do a bit of preparation. Bagilah speech sikit-sikit kan, patut. So that was me. Back in probably look at my hair. Well, there's no white hair. Okay, that was me with Mahathir and Rahmat and some officer at the back there. I think a few questions that were asked by Dr. Mahathir, Tuan Mahathir ni, dia tanya, how do you create these layers of slab? I mentioned about this can be do layers. I said put plastic in between the slab and then you can repeat the height you want to do more slab. Then last kali tanya, you ni pada company mana? Where do you come from? Which company you are? So I was telling him, I'm just architect. Just this part of my probably social obligation at that time. Then because with this, I was working with City Hall, it is a long story about this, but this is because of this so-called steel kind of material used here. So I just take a bit to show you what I was doing at that time. So City Hall at the time was doing an apartment, very small room, one room, the most is 2 bedroom. How can you develop family with 2 bedroom? So the intention is probably this is my first experiment. If it works, and I'll do something for the nation. Okay, so that was back in 1993, 9 December. This house was built very fast. Yeah. Completion date is February 1994. At that time, Mahathir came. I think it's about same experimenting. It is about slightly more than 3 months, about 3 months. 3 months. Just for experimenting at that time. So it's only about 900 square feet or about 1,000 square feet. You don't believe the cost only 20,000. That's what we spend. For this kind of house, you're talking about building, it's about 100,000 plus, more than that, 1994. So we thought that we can do something fruitful for our project to tell the government that my mission here is not to build a lot of these houses so that I can make money from there. No, it's not that. This is my thesis to say government that, hey, this government, we can build something is cheap and yet you can create a 3-bedroom unit. I show my intention. This is the reason why we do this research. Pamphlet casting, this in Bahasa because I was presenting this during the IBS seminar that day. To say that we're looking for a technique, new construction technique that can build very cheap for low cost. But not only that, we can build it cheap, but also we are not sacrificing the quality of the house, especially to provide a room for family development. So that was our intention on building this. And then we're talking about, about Nakli of 3-bedroom. At that time, people never talk about 3-bedroom. 1994, 1993, people never talk about 3-bedroom unit. All they have only a single bedroom and 2-bedroom. The one I did for the City Hall to put up the 70-story 2 block of houses in Sentul Selatan, basically they have only 2-bedroom and 3-bedroom. 1 bedroom and the 2-bedroom. The reason why that there's lots of squatters around the area, they just want to move squatters into this flat. So that was the reason. But they don't talk about how to develop family. So what happens that, of course, my perception at that time, I don't think they can develop family because most of the family they have more than 3 kids, at least more 3 or 4, 5 kids. Some sleep on the corridor, some sleep at the balcony, some don't sleep, probably they loiter around, and then it involves some bad kind of social. It becomes a social problem to the place. Apparently, I was told maybe one day this building will be demolished. But you go now, it's already been demolished because of so much social problem. So basically, if you're talking about Nakli, the 3-bedroom was not actually thought at that time. So I thought that was a Nakli at that time. I never thought about the word Nakli first. Nakli, there was not word Nakli in my mind at that time. I thought Islamic was still talking about, we need 3-bedroom separate the parents and the boys and the girls, right? So then the third intention, our design intention, basically to change the perception of the so-called the image of low cost. Mostly basically it's very shoddy, they use very cheap materials, and then it's no quality of material. So that was the kind we want to change. Most of the time, this kind of local, they use if it is a terrace house, they use asbestos sheet, corrugated asbestos sheet, so very cheap, and then they use brick block without plaster, so it's even cheaper. So it looks very not good environment to live around. So there was we designed this kind of room space for 3 bedroom with about 648 and altogether about 688 688 square feet altogether with quite a luxury living room and dining room, a separate toilet and bath, so that they can use two at the same time. And then you got all the bedrooms are all there. So we experiment. I was at that time very active, being a young architect at that time. Maybe I move around. I climb up a minister's office, Dato office, a state secretary's office. I move around wherever I can see. I just try to present my case. I say I want to build something, which just give some advantage to especially the Muslim community, the Malay community that need this kind of houses with their family. So I apparently when I met the Deputy Chief Minister, he agreed with the idea. He was the chairman of Penang Economic Development Authority, Perda at that time. So he said, okay, come, I give you a project. Okay, but besides that, not only the single floor, the ground floor, in case the owner of the house wanted to extend the space, I could even I could even pre-design an attic for them, which can be lift up easily, because I don't have rafters. I just must have I don't have trusses. You have only a rafter, so that can be done. But at the moment we have not done that yet. Yeah. So this is just allow in case the family expand. Maybe they got 4 or 5 people, then you can use this space as another annual living space. This is section how it look like. A simple house, but we change the material. We are using concrete wall at the same time. We're using the roof tiles. Okay, because the perception. Okay, okay. This is where the welded white concrete fabric is being used for my rough foundation. Okay, when I mentioned to you that the Deputy Chief Minister of Penang, he awarded me this project by design and bid, meaning say that I'm the architect, I'm the contractor. There's no other people, no other people involved. Of course, I got my engineers. I'm the contractor, so I own the project, I run the project myself. So I use this wired so-called welded wire fabric as the what's called reinforcement for the foundation. This is a rough foundation. If you are talking about using a pad foundation, we'll talk about foundation later on. It will take time, it will be costly because it involves labor and whatnot. So in my case, I just put up the sand blinding, put out the hard core below there, sand blinding, and put this put the position of column, the reinforcement there, and then lay all this fabric on the ground. So that is very, very fast. So this is how it looks like, once you bring in the concrete mixture. Before. Okay, this is how I did. We even experiment to create some insulation, what do you call this, material. See the white piece, that insulation material, especially for those building or wall that is facing the evening sun, because concrete can absorb the heat is so fast and it can release the heat at night. It can be quite warm, quite hot. So they have a cassette on my wall panels there. You see the reinforcement are all intact. My only so-called formwork is just 4 inches or 100 mm surrounding the so-called the wall. Tile roof. Tile is expensive. It's only probably for medium cost houses, because we want to change the perception of low cost at the time. I said, why not the best? We try to work out to make sure that the image of the low cost houses has been changed, to be changed to a new image. This is how talking about repetitions of wall. I can just put a few layers of wall having the same size. You can see that there's a plastic layer in between. The plastic cannot be very thick. When it's very thick, it starts to fold, and then you create a lot of lines. Plastic must be very tough and very thin, and tough and thin. So that when we put in the concrete, then it is like the concrete is pressed over the plastic, so that doesn't have so much of unfolded groove line. It's very fast to do it. And then you see the site is very clean. There's no workers, nothing, not much of debris. I mean, talking about construction, formwork kind of thing. So it's messy. Most of the site is quite messy. In our case, it's very, very clean. So that is how we do it. This is the end of the product. So 1994 was completed about 6 or 8 months. I can't remember. I think about that's in the year, of course. This is kind of building. We are talking about changing the concept of low cost. Talking about perception. Instead, you still got this is the DBKL Deputy Director, Datuk Gani, Governor Penang at that time, Tun lupa dah Governor Penang, was sometime back 1994. And we got the Chief Minister of Penang also come here. See the young man there trying to explain something. And then you got the Deputy Minister PM at that time, Anwar Ibrahim at the time is very young. Yeah, they are too curious about this house. I can't be so cheap, with all the good materials, using my own technique of construction. And we got this Tan Sri Anwar Musa, very young at the time. Look at my hair. I don't have hair. It's so. I like this photograph actually. Remind me of all this. Tan Sri Musa was time is Menteri launch. Anwar Ibrahim at that time was deputy minister. He came in for the launching. He was saying that it's big, big, big. That's a word they mentioned to me. The house is big, big, big. So I was planning to turn Governor of Penang in the top right photograph there. I was asking something special there. I said, one thing about this house, that the termite cannot come through through the floor. Because why? I have a rough foundation that stretched out from end to end of the terrace house. There's no cold joint. Cold joints means that you have, for example, the normal construction, you put a pad footing, you got a ground beam. You cast ground beam first. Then, in the video just now, when the concrete they create, there's a small gap that termite can go inside. And then they will attack your door frame, your what they call this, your architrave on door frame, and they will attack the rest. So in this house, I guarantee you, there's no termite will come in. Okay, from the floor instead of like to me, this window opening is very important in actually living in community kind of environment. Whereby kalau you are talking about sometimes you sitting, if it is a normal kind of height window, 900 mm, you cannot see who's outside. you're sitting on the couch like this, you can open up the window, you can see who's outside. I mean to say that in case you want to talk to somebody, you see the pakcik coming through, you want to talk, pakcik, apa, kata, I want to, ni nak cerita sikit ni kan. Then you can, there is some visual communication with the, you know, talking about this, you know, I was called to come up with a draft with the Jawatan Perumahan Negara, and then the beauty about this, the beauty about this project, basically, the government agreed to create a 3-bedroom unit for low cost. That is my thesis end there. Okay, this end there. Okay, but of course. Same what what I've done. And since okay lah, do one for them. But after completion, they claim that this their first developer in client, but normal contractor they charge this. It depends because I don't have any quote unquote toll in between. Toll is no. For building a low-cost house because of so-called knuckly. When I come to SIM, now I realize what is knuckly so important. All right. So this is very small contribution, but no, it's another big project here just to give some indication. Buildings. So you know KLCC, everybody knows about KLCC. I don't have much info, but I just want to show you something that a lot of people thought that this building is built by steel frame, which is not. It's by consistent edges. Arian, do you want to say anything? Anybody want to say anything? I heard some voice at the back there. Okay. Tak ada service core. Later on, below, even your 6th semester, lift core. Lift core basically they house all the number of lift, services, toilet, risers, all the piping, the firefighting, the electrical, whatever, all in the service core. The rest are all lettable area or lettable means office area. So you see this mega column, they call it. There are about 16 of them. You know, they're all made of RC wall, RC concrete, RC column. So of every night to dig down 30 meters below the surface. You can see the retaining wall. Where's my cursor? Here, the top. See the retaining wall here? It's more than 30 meters. Yeah. This is a 2 block. Okay, so one is constructed by Japanese group, the other one by Korean group. You can cut the detail from internet ada lah ya. So this so-called the dig below, even this later on will become underground parking. Yeah, they have done it all together so that they just put a structure for underground parking. Yeah, so basically they have to do it at night because in 1,200 cubic meters of concrete. I can imagine how big it is, but by the number you can imagine is just for the foundation, because the foundation is about 15 meter thick, 15 feet thick, 5 meters. So which was continuously poured through a period of 54 hours for each tower. Just imagine that more than 2 days they never stop pouring the concrete because they cannot be stopping it because they have to have a very shall I say they cannot break because they be when I talk about coil joint kind of thing, the concrete have been continuously pouring all the time. That means it become one, you cannot have any break. So it spend about 54 hours. Is now encased in steel and vision glass. The tower feature multifaceted wall of 33,000 stainless steel. This stainless steel. Stainless steel is the most expensive steel. Remember, we learned from the sun, 1,000 glass panel, 55,000 glass panel. So in terms of area, it translates into like 85,000, 83,500 square meter, or about more than 90,900 over 1,000 square feet of cladding, and then about 7,000 of glass, vision glass. So kalau talking start, so quite a challenging kind of thing. But anyway, this is kind of routine. How much the tower weigh? So basically, the tower weighs about 300,000 ton, equivalent to about 165,000 cars per tower. I mean, talking about weight lah. And then of the total weight, uh, of the elephant. This I aside from the website. How much big? Mentioned there about 213,000, but equivalent to about 30 football field per tower. So how long the bit? Of course, normal they were talking about achievement. This is how the foundation been poured. Or the slide should become earlier, so I probably missed out the slide. Just imagine the kind of piling they involve here. 104 piles that goes like from 200 to 374 feet to reach the depth. This is so in world record, is 200 to 374 feet. You divide by 3.28, you get the meters. But again, before they actually place the building position, and they do the soil test, there was a soft rock and a limestone in place of the under the so-called meter deep slab. They call with a pile and rough foundation. Just imagine the amount of cubic require enormous amount of concrete to Yeah, 470,000. It's not 4,000. Sorry, it is 470,000. Yeah, 470,000, which is the largest quantity port during 2007. Again, 52 hours. So basically, foundation took 12 months to complete, 1 year to complete foundation alone. This amount of work is a lot enormous. Actually, the work scope in terms of just record lah, yeah. About 12 months to complete. So this is for us to know about this project. So a lot of concrete used here, yeah, including this. Look at the kind of they call it mega column, the round column here, huge column. By the look of the scale of the kalau you're talking about efficiency of the building, I don't think that this building quite efficient because the core will take up so much of space. Maybe it's about 40,000. Sorry, 40% of the floor space. This why they got to create another circular office space here in front to sort of counter or to add the amount of floor space because the core has been taking so much of space. Normal construction for office building is about is a way of talking about feasibility and getting the return. It's not that good in a way. But of course, the rental for Petronas Tower is expensive, very expensive. Although those blue chip kind of company, big, what they call it, see you can see the building going up, in phases over the time. At that time we were over time we don't have the patience to wait when it's going to be completed. But at the end it is completed. Now we can use it. You know why? Because at the time Mahathir said we need to actually shout. We are just a small dog, barking at the hill. Nobody listened to us. So with this know Singapore very well. So Malaysia was not known at the time, back in especially in before the 80s, was not made known. So with this, so you don't have to shout anymore. The small dot doesn't have everybody know that you are there. So that's something actually to spark off the growth at that time, where the economy, people recognize us, that we can do such kind of bidding for a small country. We at that time were very small capital because again, with the bless of God, we found the petroleum. So this all is petroleum money that can actually bring us or upgrade our standard of living and even the country for that matter. Okay, I think probably this is all for today. Yeah, it's all for today. Unless you have any question, then we can actually go through the question. Okay. Guys, maybe, but it's just anti-climax lah. I should show this earlier. In fact, I wanted to omit this, to delete this, but since it's here, we can share something. It's about the failure in the reinforcement. My biggest mistake in BIM.
Assalamu alaikum guys, welcome back to Civil Engineers YouTube channel. Today I am on this construction site and I will show you some big mistakes, especially in RCC top beam. Okay, this is slab beam, top beam. Okay, so let's start guys. First of all, I will discuss the size of the beam. Okay, the width of the beam is 12 inches and its depth is 16 inches. Okay, 16 by 12 inches is the size of RCC column. Now here at the bottom we have
Beam.
4 steel rods, which dia is 16 millimeter. But at the top we have 3 steel bars, 3 rods we have at the top, which dia is 16 millimeter. Bottom bar and top bar dia is 16 millimeter. Okay, so now guys, what's one? The first one mistake, guys, you can see this is near its support. Support is what? RCC column. Look here. But we don't have crank bar, bent up bar. But in many videos, I have already discussed that the crank bar should be provided in RCC beam to resist shear stresses at the end of the supports. But guys, you cannot see. You cannot see any crank bar. Look here. Okay, so the crank bar should be 4 length, L by 4 distance we should provide the crank bar. Okay, now guys, this is the first mistake. Okay, so now here in this beam we don't have any development length. Okay, so directly you can see we don't have any development length. Look here. Okay, so this is simple. So the development length should be provided in RCC beam. Okay, to make a good bond between as you can see here. I told you in many videos and from ACI and IS codes, okay, this is the reference, that the stirrups dia should not be less than, especially for top beam, the minimum should be 6 millimeter. Okay, but here we used 16 millimeter dia of steel bar, so therefore the stirrups dia should not be less than 8 millimeter. Okay, so it should be 8 millimeter, but they provided here just 6 millimeter, so it cannot support the shear stresses. Now guys, you can see these are the hooks. Okay, but the hooks should be provided it cannot resistance during earthquake. Okay, now the other problem. Okay, and many videos and also from STI and IS reference, they told us that with L by 4 distance the space between 2 stirrups should be minimum, but after L by 4 it should be maximum. Okay, but you can see here it is about 9 inches. Okay, this is 9 inches and sometime 10 inches, so it should be equal at the mid. Okay, but it should not be more now guys. Here in 3 or 4 story building and top beam at the mid we should provide the cut piece. Okay, from the mid. Okay, because we should increase the strength of beam at the bottom. Okay, because the top bar transfer the load to the bottom and bottom bars can okay, can give the load to the column, so therefore we should provide the extra bars here. Okay, but they didn't provide. But you should remember these points which I've discussed, especially for top beam. So guys, this is the some useful informations and big mistakes which I've discussed in front of you. Now how we can solve sometimes some mistakes we cannot solve on the side, so therefore we should remember before
Is in our case normally probably it doesn't this something which is not happening here, because every stage of work, every day, and the contract has to report what they are doing, and then the cloud work go and check. Every day they got the site, they call it diary. Use formwork, I mean, plank like this in Malaysia, they use plywood, or they use metal formwork. So you don't have this kind of opening. This opening has to be sealed off. After, if not, there'll be some bleeding, concrete bleeding. Material that is possible to do it. Probably quality is a bit different from here. Okay, guys, this is just I thought I want to delete because before the semester end is possible. Dia you duduk kat rumah tak tahu you sama ada dekat depan screen ke, ada you are not in front of the screen, you move here and there, maybe you don't pick up whatever I mentioned. Itulah yang takut sikit. But if you are there all the time, I'm sure it shouldn't be a problem. So itulah. So I guess so itu saja for today, and then we will what you call this next week, and then try to find another time to finish up the other two. And then at the same time, I know in the end of semester, everybody very busy. You got a lot of assignment other than your main design project too, which is bila submission 24th. Yeah, you want to put your title block where you put your name, your concept, you design format first, and then when you have finalized everything, you just plot in and plug in and paste or whatever is necessary. Anything you don't need to actually think, you bring it forward. Remember I mentioned to you about detail design with detail in mind. Think of the end product first, bring it forward. Unless the last kind of solution that you need to resolve, okay. So beside that, I'm sure you got other assignment yang baru sign ke your university punya uh, compulsory subject tu mungkin ada juga That's why I bagi flexible sikit when you ask me for extension tu. I understand because I don't want to force you so much to actually squeeze yourself WhatsApp je. Kalau WhatsApp I tak jumpa you punya message. Kalau you send me a text message, then kata oh Haji saya ada WhatsApp dekat WhatsApp, dekat message saya dah hantar message kat WhatsApp. Okay, then I look at the WhatsApp. Okay, I'll see you back next week insyaAllah. Okay, kalau tak apa, kita sudahi dengan Safrah Kafarah dan juga Sultan Asri. Subhanallah. Okay, insyaAllah jumpa lagi. Terima kasih ya. Dan see you next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Haji.
Okay. Alright. Okay. See you guys. In fact, I hope everybody. Amira, jangan lupa Amira ya. Thank you so much, Amira. You doing a good job ya. Thank you. Bye semua.